Hi, I'm Heino Falke from Radboud University in Nijmegen in the Netherlands. And I want to briefly talk about Space-VLBI and jet launching. The amazing thing is that nowadays we can see jets from the larger scales all the way down to the event horizon, at least in one case, M87. And we can do the same thing in simulations. We can simulate jets and jet formation in big computer simulation, GRMHD, General Relativistic Magnetohydrodynamic simulations. And we can actually very accurately reproduce the jets that we see, which seem to be edge brightened, where the sheath is radiating, which are beamed, which are powerful. We see the shadow, we see the jets. So what we need to do in order to improve our models is to get higher resolution and really transversely resolve all the structures in jets and how they connect to the event horizon scale. Because at the event horizon scale, that's where jets are made in supermassive black holes, either via tapping into the spin of the black hole or into the power of the accretion flow. And the way to do this is to actually do space-VLBI. So far we had VLBI on the ground with limited baseline coverage. If you want to have a higher resolution image of jets, you have to go into space. But if you only have one antenna in space, you have to always connect to the ground. And your coverage of baselines is not very good. If you, however, have 2 or 3 spacecraft, they don't have to be very big, in space at slightly different orbits around the Earth. Then they will orbit at different time scales and they will drift apart. They will rotate around the Earth, this configuration. You have baselines of all lengths, of all orientations. You get a wonderful, almost perfect filling of the UV plane. You can make wonderful images. And that's shown here in this simulation, where is a model of M87 at 230 gigahertz. On the left side, you see the model, you see the light ring, you see the shadow, you see the forward jet with its launching point, which is actually in front of the black hole shadow, and you can recover those from space extremely well. You can even make movies of jets and compare that to simulations. So I think jets will be understood once we go into space, and it's intimately linked to the physics happening at the event horizon. And these are very fundamental effects, like the Blandford-Snark effect, really tapping into the spin of black holes. Is related to the Penrose effect, which is a fundamental effect of space-time. And Space-VLBI can really deliver us, I think, that information and probably seal that question forever.